So we are going to go on to our second video and talk about matter some more and start looking at some of the things of chemical and physical properties of matter. So let's just review matter just a little bit. So matter, can we physically separate it? If we cannot, it's a pure substance. If we can, it's a mixture. Okay, so let's go to pure substances here. If that pure substance is made out of just one element, it is an element. Can it chemically be decomposed? No, so it would be elemental. If it can chemically be decomposed, it is a compound, meaning it's made out of two or more different types of atoms that are chemically bound together. Let's go back to our mixtures. Mixtures can be physically separated. Is the composition uniform? If it's uniform, then it's a homogeneous mixture. Homo, remember, means same, so it would be uniform. If it's not uniform, we have a heterogeneous mixture. And heterogeneous mixtures are classified on what kind of size of compounds or particles they have. So if they have small particles that do not settle out, they are colloids, like mayonnaise, lotion, those kind of things are colloids. But if they have large particles that do settle out when it's not mixed or shaken or stirred, we have suspensions. Okay, so here we go. More things. I want you to take a minute and classify these compounds as either compounds, elements, heterogeneous mixtures, or solutions. I'll wait for just a second. You can pause the video. Okay, have you gone through this? Water. Water is made out of H2O. So, but it's pure, right? I can write a formula for it. So this is what we call a compound. Okay, cologne or perfume. We know that that's a mixture, but that mixture is uniform. So it's uniform, it's a solution or a homogeneous mixture. Aluminum foil. What's aluminum foil made out of? Just aluminum. Aluminum is an element. So aluminum foil is an element. Oh, 14 karat gold. This one's kind of tricky. 14 karat gold tells us the purity of that gold. We don't use pure gold to make our jewelry here in the United States because guess what? Pure gold is actually a really soft metal. So we put a little bit of silver and a little bit of copper in there to make it a little bit more robust and a little bit more strong. So 24 karat gold is pure, but 14 karat gold is not pure. It's actually a mixture, and it's a uniform mixture, so it's a solution. It's a special type of solution that we call an alloy, which is a mixture of metals. Carbon dioxide. I see carbon. Di means two. Oxygen. So I've got two types of atoms here. I can write a formula for it. So it is a compound. Okay, a Twix candy bar. We've got layers in here. That's definitely a mixture. And I've got layers. I can actually see the different layers. So it's a heterogeneous mixture. Okay, milk. This one tricks people because guess what? On the side of milk, it says homogenized. But you know what? It really isn't homogeneous. It is heterogeneous. You've got little chunks of fat floating around there, little chunks of protein and things like that. It is a heterogeneous mixture. It's just that the little bits of particles are so small that they don't separate out. So it's a colloid. Okay. Air. What is air made out of? It's actually a mixture of nitrogen and oxygen and some various other things. And it's a mixture. It's pretty uniform. Could you imagine if it wasn't uniform? We wouldn't be able to breathe at certain parts in our our daily going about our lives. So this is a homogeneous mixture, so it is a solution. And yes, we can have solutions of just gases. We can have solutions of solids like that metal. Solutions don't have to have liquids in it. Blood. Blood have you ever had blood just sit? If you take your blood and have it in a test tube after about 10 minutes, all the red blood cells come down here to the bottom and all the plasma and white blood cells float to the top. It is a suspension. So it's a heterogeneous mixture, sorry. It's a heterogeneous mixture and it's a suspension. Brass. Brass is actually a mixture of a couple of different metals. So when we look at brass, we have zinc mixed with copper. So it is a solution. How did you guys do? Okay, states of matter. Solid. We all know what a solid is. In chemistry, we put a little s in a parentheses. Solids are, they have fixed volume and they have fixed shape. Liquids, we designate that with a little L. They have fixed volumes, but the shape is they take on the shape of the container. And gases, we designate with a small g. They have no fixed volume. In fact, they will take up the entire volume of their container, and they will take the shape of their container too. Okay, so here's a representation of how a solid looks on a molecular level. Notice how nice and orderly it is. Everything's packed nice and close together. We actually have a crystalline structure. Solids do have crystalline structures, even things that we don't think that have crystalline structures. Liquids, they're still relatively close together, but notice they don't have as much organization. They can move around. And then gases. Those molecules are super far apart from each other. They're moving quickly. I like how this shows the movement of those gases because gases are moving very quickly. Okay? Physical versus chemical properties. Okay? A physical property is a characteristic that can be observed without changing the material. Oops, I don't want that. And I don't want to go back to the beginning here either. Let's get to where we're at. So it is a property or a characteristic. Why does that do that? It's not what I want. It's probably me resting my hand on here. That can be observed without changing the identity of the substance. Okay? So for example, if I have, let's just grab an object here. If I have this pencil, I can observe that this pencil is about 10 inches long. I can observe that it's yellow. I can observe that it's got this aluminum band around the top. I can observe that it's got an eraser. I can observe all of these things without changing its identity. It still is a pencil, okay? There are two different types of extensive or physical properties. They're extensive and intensive. So extensive are things that are properties that do depend on how much material we have. So properties on the amount of material. So an extensive property would be something like, how much mass do I have? How long is it? How much volume does it take up? Those are extensive properties. Intensive properties are properties that do not depend on the amount of material. Okay, so for example, with that pencil, we could have color, conductivity, whether it conducts electricity. What else would be a good extensive property? Density, boiling point, melting point. It doesn't matter how much I have. Those properties don't change, okay? Chemical property, on the other hand, is a little bit different. It's the chemical, I'm going to change color just so that things don't get so blurred up. Let's change to green. Chemical property is a property that is the ability of a substance, and it could also be the inability to react or to undergo changes into different substances. Or react to make new substances. Okay, the key word here is this new. Anytime we are doing a chemical property, we are changing the chemical composition from what we started, okay? So I want you to take a minute or two to go through these properties and identify them as chemical or physical, and we'll check in just a minute. Okay, so take a minute. Let's look at this. Copper conducts electricity. Is that a physical or a chemical property? That is a physical property because I still have copper even after I put electricity through it. And that is an extensive property. It's an intensive property. Oh my goodness. That's an intensive property because it doesn't matter how much copper I have. It's still going to conduct electricity. So that's an intensive property. Sugar dissolving in water. Does the sugar actually react with water when it dissolves? No, it doesn't. It still stays sugar. So that is a physical property, and that also is an intensive property. It doesn't matter how much sugar I have, it's going to dissolve in the water up to a point. Copper reacting with nitric acid. The key word here is react. If I'm reacting, I'm doing something chemically. So this is going to be a chemical property. Gasoline is flammable. Well, we know that burns, right? That's a reaction, isn't it? So this is a chemical property because that gasoline is reacting with the air and creating a fire. Density. Density is definitely an intensive property. It doesn't matter how much I have of a subject, it's always going to have the same density. Iron rusts. Doesn't that change the chemical composition of iron when I rust? Yeah, it does. So that is a chemical property. Lead is malleable. This is probably a word that a lot of us are not familiar with. Malleable just means that I can bend it, I can shape it, basically, metals are malleable because we can bend them, we can shape them, and they still don't break. So lead being malleable, that is an intensive physical property. I should put physical properties there. Okay, how'd you do? All right, so let's look at copper and physical properties here. So physical properties of copper, it's reddish brown and shiny. It's easily shaped into sheets. It's malleable. I can draw it into wires. That's a different thing. That's called ductility. It's ductile. It's a good conductor of heat and electricity. It has a density of almost 9 grams per centimeter cubed or milliliter. Its melting point is a little over 1,000 degrees, and its boiling point is about 2,500 degrees. Chemical properties, it forms a green copper carbonate compound when in contact with moist air. Maybe like the Statue of Liberty? Reacts with nitric acid and sulfuric acid, forming new substances. That's a really nasty, nasty gas comes off of that reaction. One type of compound forms deep blue solution when in contact with ammonia. It also will create deep blue water solutions as well. Okay? Physical properties of substances. Oxygen is colorless. It's a gas at normal temperatures. Its boiling point is negative 183. Water is colorless. It's a liquid, and its boiling point is 100 degrees Celsius. Sucrose or table sugar is white. It's a solid, and it decomposes, so it burns. It doesn't really boil. And sodium chloride, this is table salt. It's white, it's solid, and its boiling point is 1,465 degrees. Okay, take a minute to look at this, whether this is intensive or extensive. Okay, have you made your guesses? Gold has a mass. Doesn't mass measure the amount of an object? So that is going to be an extensive property. It matters how much stuff we have. Extensive. I can't spell. I give up. I'm just going to put an E here. Gold is unreactive. It really doesn't matter how much gold we have. That is an intensive property of gold. A piece of silver has a volume of 1 centimeter. That volume tells us how much we have. So that's an extensive property. And water is colorless. That's intensive. It doesn't matter how much we have. So how did you do? All right. Last but not least, elements are pure substances that cannot be separated into simpler substances. There are 92 elements that occur in nature. Several others have been created synthetically. The names and symbols of elements are universally accepted by scientists in order to make communication of chemical information possible. In this class, there are about 55 of those elements and symbols that I want you to know for this class. They're listed in the front of this manual. We're going to go column by column. So 11 of the elements have symbols that are derived from the name other than English. It makes it kind of difficult for us to understand them sometimes. So here we go. Here are the non-English derived names for the elements. Iron. This is a Latin name, so we call it ferrum or Fe. So why do you think the Ferris wheel has its name as the Ferris wheel? Maybe because it's made of iron? Okay. Copper. The Latin for copper is cuprum, so our symbol here is Cu. Okay, lead. The Latin for that is plumbum. So the symbol for that is Pb. That's why we call plumbing, because it was made out of lead. It was made out of plumbum. Okay, and then let's see. It looks like I am losing power. So let's give this some power. There we go. Tin, stannum. The Latin for tin is stannum, so we call tin is Sn. Okay, gold, aurum, Au. How many of you guys grew up watching Sleeping Beauty? Remember they called her Aurora? Aurora is another name for dawn because of the golden sunlight that happens at the morning when the sun first comes up. So aurum is gold. Silver, argentum. R-A-G, argentum. So what do you think they were trying to find when they settled Argentina from Spain? Maybe some silver? There was legends of Argentina having mountains of silver. They didn't find the silver in Argentina. They found it next door in Chile. All right, mercury, hydra argentum. Hydra means water. Argentum is silver. So silver water. If you've ever seen mercury, it does look like silver water. It's pretty cool. Highly toxic, but very cool to watch. All right, sodium, natrium, also Latin, Na. So guess what? This is the root for nurture. I know it doesn't really look like it now because we've changed it so much in English, but back in the day, Roman soldiers were actually paid in salt. So the state would nurture their soldiers with salt because guess what? We have to have salt to live. That's why we call what we are paid salaries. Salary in Latin is also salt. Okay? Potassium, kalium, that goes by a K. Antimony, stibium, SB. And this is our one non-Latin one. Tungsten is named after the German Wolfram, so its symbol is W. Okay? So take a minute. Let's look at the periodic table. See if you can find the symbol or the name for these. I'm going to give you a minute. Stop the video. Okay, have you finished it? All right, the symbol for oxygen is O. N is the symbol for nitrogen. Calcium has the symbol Ca. Br is bromine. Okay, nickel has the symbol Ni. I is the symbol for iodine. Zinc, Zn. Mg is magnesium. F is fluorine. Now this is an interesting thing. We usually want to spell it like flour. It's different. The U comes before fluorine, so be careful here. Uranium, the symbol is U. S is sulfur. And a lot of times we want to do an ER, it's a UR here. Hydrogen, the symbol is H. Carbon, C. Silicon, Si. He is helium. And aluminum is Al. In Britain, they call it aluminium. So if you watch some of the British movies or YouTubes, that's what they will show you. Anyway, that's what we're going to do for today. We'll stop this video for a second and get you set up for homework.